Have you ever wondered how a simple piece of code goes from just a list of instructions to, well, something that can actually make decisions, solve problems, and seem almost intelligent? Well, today we're going to pull back the curtain on the fundamental building blocks that actually allow a Python program to think. So let's think about a program's life less like a straight line and more like a journey. It starts out simple, but it very quickly learns how to navigate forks in the road, how to repeat tasks super efficiently, and maybe most importantly, how to handle those unexpected roadblocks. This, right here, is the secret sauce to how code becomes truly dynamic and powerful. All right, let's start at the very beginning, ground zero. Before any program can make clever choices or juggle complex tasks, it has to master just one thing, following a simple list of orders. This is the absolute baseline, the starting point for every single program's journey. This is the program's default behavior, and honestly, it's a lot like following a recipe. I mean, you don't mix the ingredients for the frosting before you've even baked the cake, right? Of course not. You follow the steps in order. And a Python script, it does the exact same thing. It executes your code one line at a time, from top to bottom. It's simple, it's predictable, and it's the solid foundation for everything else we're about to build. But let's be real for a second. Just following a list isn't very exciting, is it? Real-world problems are full of what-ifs. What if the user is under 18? What if they type in the wrong password? A program has to be able to make choices to handle these forks in the road. So how in the world does it decide which path to take? Well, it chooses using what we call conditional statements, and the absolute star of the show is the if statement. It's basically a simple contract with your code. You give it a condition, and you say, hey, if this thing is true, then you're going to execute the specific block of code. And if it's not, well, the program can either just skip it, or it can check another condition with elif, or even run a default action with else. It's this beautiful, structured way to handle any possibility you can think of. And check this out, because these operators, these are the actual tools the program uses to test those conditions. This is the grammar of its decision-making. So instead of some vague question, the code can ask something really specific, like, hey, is the shopping cart total greater than or equal to 50? Or is the word apple in this list of fruits? This is how a simple if becomes an incredibly powerful tool. And this example right here just brilliantly illustrates how powerful that can be. Look, the code isn't just checking one thing. It's asking three super precise questions all at once. Is the age at least 18? And is the age no more than 30? And is the country France? See? Only a yes to all three of those will trigger the action. This is how you build some incredibly specific, intelligent logic into your applications. Okay, so our program can make choices now. That's a huge step. But what if it needs to do the same action over and over and over again? Like, say, for every single item in a customer's shopping cart. I mean, writing that out by hand would be an absolute nightmare. So instead, we teach it to run in these productive circles using loops. So Python gives us two main tools for this. First up, the for loop. This is your go-to when you have a definite collection, like a list of emails, and you need to do something to each one. It's super reliable, it knows exactly when to stop. But then you have the while loop. This one's different. It's not about a collection, it's all about a condition. It's just going to keep running as long as a certain condition stays true. Now, this gives you a ton of flexibility, but it also comes with a pretty serious warning. And yep, this is that warning. If a while loop's condition never, ever becomes false, the program gets trapped. It gets stuck in an infinite loop. It'll just run forever, eating up memory, eating up your CPU, and never moving on. This is a classic pitfall, and it's exactly why every single while loop you write absolutely needs a guaranteed way out. Luckily, you're not just along for the ride here. You'll have some really fine-grained control. Think of break as the emergency exit. Maybe you're searching a huge list for one specific name. The second you find it, you can break out of the loop right then and there. No need to check the rest. And continue? That's kind of like hitting the skip button. If you're processing a list of files and you find one that's corrupted, you can just continue to the next one without stopping the whole process. So our program is getting pretty smart. It can follow a path, it can make decisions, it can repeat actions like a champ. But the real world, it's messy. What happens when something completely unexpected goes wrong? An error, like a user trying to divide a number by 0, or the network connection just suddenly drops. A naive program would just crash and burn, but a robust one, it has a contingency plan. This kind of roadblock is called an exception. Now, The really critical thing to get here is that an exception interrupts the normal flow, but it doesn't have to end it. Think of it like an alarm bell going off. It's a signal that something unusual has happened, and it gives your program a chance to respond gracefully instead of just throwing its hands up and quitting. And here is that contingency plan in action. You wrap your risky code, the part you think might fail, in a try block. This basically tells Python, okay, attempt this, but be prepared for trouble. Now, if an error does happen, the program doesn't crash. It immediately jumps to the accept block. That's your backup plan. The else block, that only runs if everything went perfectly. And the finally block, that's your cleanup crew. It runs no matter what, making sure things like open files always get closed properly.
So we've seen the what, but let's talk about the why. Why is this concept so absolutely critical for building professional, reliable software that people can actually depend on?
Because it's the fundamental difference between an application that feels brittle and one that feels robust. Instead of your program just crashing with some cryptic error message, proper exception handling lets you catch the problem and tell the user something helpful, like, oh, sorry, that file doesn't seem to exist. Can you please check the name and try again? It transforms a catastrophic failure into a manageable hiccup, and that is what makes code truly reliable.
And just like that, our program's journey is complete. It started on a simple, straight path, just following orders. But now, armed with conditionals, loops, and exception handling, it's equipped for a much more complex world. It can make choices, it can repeat tasks, and it can create contingency plans. You see, these aren't just features, they are the core tools that give code the ability to think. So remember, these aren't just abstract concepts. They are literally the map and the compass for any program you'll ever want to build. Now that you have the map, the only question left is, what journey will your code take?